the first point, the first how to say, the first implementation we do is the non-linear analysis. This will permit to have two modules in the program. We call it NLD and LLT. Don't pay attention of this name. It will be the module. But what do this module? The first one permit to analyze uplist or compressive behavior for node with external fixity and shell with subgrade modulus. That means that if we are in Cype 3D want to analyze something like a math foundation, we'll be forced to put it like a shell, and we can define this shell with this property, non-linear element. So only we analyze compressive behavior. This will be very important. And also it's very important the tension member for behavior, like generic bar. This will use it to replace the traditional tie we use in the Cype, which have a lot of restriction to be used. So finally, you see that the implementation is very easy in the program because you only have to define the external fixity and change the description. In this case, when elastic behavior is being assigned in external fixity, you have the possibility to give if positive or negative value. If we are not talking about a non-linear element, we have the two directions. But if non-linear analysis, we have the possibility to have only positive, only negative. Later, we'll see it in the program. Also, you see that if a bar have to be used like a tie, not a conventional tie, we have to describe it like generic bar, and we also have the behavior on only tensile behavior, only tension behavior. So in the shell, when we describe the shell, also if we assign a subgrade modulus in this shell, we also have the non-linear behavior by changing only compression. Later we see it. So let's advance more to see. Then the second point we will see also is the global stability, how the program will help us to give the buckling length. So it will give us the coefficient to be assigned in the bar to have the buckling length. So program have an advanced method we will be used to calculate the eigenvalue for all the mode we choose, and we permit to assign the coefficient we need to verify the bar working in compressive forces. So in the third point, to make it is possible, we have a new engine we are using, which is OpenSys. You can see the advantage to use the OpenSys that this engine is secured, tested, and certified. And this engine is optimized for treating with multitask or use of several processors available in computer. That's exactly what will happen when we try to make a non-linear analysis. We will use the calculation for any combination because the superposition is not available in this case. That's why we need a lot of instances of OpenSys to resolve each combination which are not linear, and Cype will treat the result. So the third point of using OpenSys like a tested engine will help us for this task is Cype keep focused on the development in pre and post treatment of information. So the post operation will be made in OpenSys. So let's continue. If we come back with the first implementation, we talk about the non-linear analysis, we can make a simple resume, a comparison. The linear analysis we make at this moment, we use it because we assume that the deformation are very small. There are no big deformation. In non-linear behavior, the deformation are very big. That's why we need this implementation. Also, when we are making linear analysis, the superposition effect is accepted. But when we are making nonlinear, we have to make analyze for each combination we can define in the job, or the program can help us to generate it. And in the last comparison, the linear analysis will permit to simplify calculation, and the nonlinear will make it complex. But this is the setting normally we have when we create a combination. We will be analyzed like nonlinear. We can set it to be act or no, so we have in the list. And since the load is being applied by steps, and we have the option to optimize this, and we make iterative process. So we have a lot of parameters, the tolerance, the iteration, and the reactance. We are default value to be changed for the user. Normally, the default value Cype give is sufficient for that. No? So this is why we have to show the use of the nonlinear. In which type of job will we apply it? We already say that when we try to simulate a math foundation, or when we are using element, we are only working like a tension element. In this case, when we are putting tie in traditional structure like this. In this tour, where we have only element, we will work like tensive element. We have now the possibility to make a direct analysis. We don't need to only analyze linear compatible with the forces we introduce. We can put all loads and simply use this mode, do this nonlinear analyze to analyze all the load input, no, without making alternative analyze we usually do. So in the part of the buckling analyze, we can set that for all combination we can set, or the user can set to the program. And for all the mode, we also indicate in the program, we will calculate the eigenvalue. And from this eigenvalue, we have the factor of load. And also with this information, we can calculate the buckling coefficient. And to finish, we have a sensitive analysis of participation. This will permit the program to assign the coefficient of buckling length for every element, using, of course, this formula to permit to give the beta value, no, according to the inertia of the section and the axle of the combination we analyzing. The value of the factor of the load will be calculated. No, once we know the eigenvalue, that means if we know the eigenvalue, we know the critical normal force, huh? And we also know the normal force in the combination. It's very simple to calculate the factor of ampliation of the load. So this will be done internally. We see that in the buckling analysis in bar described, we have the possibility to tell to the program which bar will be considered in this calculation of the buckling analysis. So it's normal to think that the user know that not all bar will be analyzed. No, the more we put all bar, more we have problem to time for analysis. So some sensitive bar we are working a compression will be the focuses to change it. You see that in the describe bar we have this possibility to set which bar will be analyzed, and later in the buckling analysis we can analyze it and see the buckling mode, and of course we can see the result by any combination analyzed and any mode analyzed. These are the settings for the running. So with this information, please let go now and see how we implement this module in the program. If we start with the nonlinear analyze, we can see that in this job, I already introduced a math foundation, but I make it with the shell. So if we go with describe this section and we make a double click, we have this information. We simply add the behavior. In the last version, we didn't have this option. This change, this will say to the program that there is an existing nonlinear element to be analyzed. In this case, we only put the behavior like only compression. Normally, in the past, we do it like linear element. So we analyze that we can have compression or traction in the spring the program used, but now we're only forced to have compression, which is the behavior of the soil. This is very simple. We introduce a shell. When we are introducing the shell, we describe the behavior like a nonlinear element. If we come with bar, in this case, we have a lot of ties, a strategy of ties we introduce to help us to don't have lateral, to resist lateral deformation. So if we go with bar describe and we describe this bar, you see that I grouped them. So that's why when I choose one, I choose all. So if I right click, you see that I describe this like a rounded bar, but I have this button, this new command we was implement in this version. We permit to change the linear or non-linear behavior. So in this case, I change it only to only tension. So what we do in the past when we have this, we have two options. The first, we use the tie option. The tie option is a simplified method to approach the non-linear we already created, but it have a lot of restriction. We have to use it in the orthogonal frame, in condition with the relationship between the section have a restriction which was right in this point. This don't permit, normally the analyze is correct, is quickly, but it don't permit to make exactly what we want to construct, because in the job, normally we don't have the tie will go exactly in this point. Maybe we want to finish it as 10 centimeters because it will be easy to make the connection. So with the traditional way to resolve the tie, we have the rigor in the forces, because the bar, anytime we work like tensile element. But when we make it like generic and only tension, it will be better. So only we have to change this condition. I'll cancel it. The rest of element, we have it like conventional linear behavior. It's not changed. Only this type was changed. So if we come back with the shell, with describe section, I didn't give right information. We change to behavior only compressive. That means that we have compressive in the Z positive direction. So people will already use this, know that there is a option here to change the direction. If the zeta direction is looking upward, is not correct. With this option, we change, reverse it. I don't want to change it because it will force me to make calculation. So in this simple model, where I make a shell to make a simulation of a math foundation, I put tie with nonlinear behavior. When we go to make the analysis, the first time we make the analysis, I will please permit me to with the nonlinear combination, you see that the program offered me all the combination which was linear. So I will analyze them like nonlinear. Normally in this point, the first time when we reach in this point, when we go to the nonlinear combination, we don't have nonlinear combination. The program was made in the way that the user can create nonlinear combination, or he can take it directly from all the linear combination. So you don't need to create it. Even this, you don't need to come to do this. Program will help you. Only if you have a professional, you want to verify a specific non-linear, you will do it and create your self combination. But in normal job, you don't have to do it. Directly, you go to analyze, and when you start the stress and strain calculation, you have the possibility to continue with a linear analysis, and you can check the non-linear. That means that the program automatically, the first time, will generate all the non-linear combination from the linear combination. And the design, depending of the element, will be made with the combination of the two groups of combination. So let's go ahead. So I don't need to create a non-linear combination. During the linear analysis, the program will generate the non-linear combination. It seems that is the first time I run this this analyze in this computer. That's why the OpenSys was installed to permit to make this analyze. So you see that the time is faster. We have a lot of combination, and the advantage of using the OpenSys permit the program to attempt these tasks with quickly, no?
So it's going through many different possibilities here, the program, different options, all of it is calculating in the OpenSys analysis engine, because the engine is the one actually doing the analysis is OpenSys, correct?
Yes, it make the analysis, and we prepare information with the combination, the matrix of the geometry matrix, the inertia matrix, and we pass it to the OpenSys. We make the analyze and give out the result, and we make the post process, no, to make the verification of element.
And for those that don't know, OpenSys is the analysis engine developed by the University of California at Berkeley's research department of earthquake activity. So it's a US engine, and it's embedded in our software. That's how we're doing these nonlinear analysis, like my colleague Antonio has just mentioned. Very good presentation so far.
Yes, well, let me talk about result now, and we do also the booking analysis. But you see, it's nice embedded in the program. You still work as you was working, and you only have to describe element. We have this behavior. If you have a shell which is we have only compression behavior, you just set this property. If you have a tie, which is a bar, no, a tie, we have only tensile behavior, no analysis. You just set it. You don't have to do much. If you are worried because you have to create combination, you don't have to do it. Program will make the nonlinear combination the first time you run the job. Simply will base on the linear combination, no? So when this process is finished, you can ask how the program does to verify elements. Those elements we have nonlinear behavior will be analyzed with the nonlinear combination, of course. An element we have linear behavior will be analyzed with linear behavior. This will be automatically made by the program. So let's see. Okay. When I was preparing the presentation, I have the job which was already run, but for me it's very important to run it in front of you, no? So you can have a check. So what can I do when this is done? if I come back with analysis, normally we use the force command to verify what is happening. That means that we can go directly to envelope, select console value, go direct to axial. When I make a click to this bar, we see that all the values are positive. That means that the nonlinear managed to give only tensile forces. If I choose this one, I will have compression and tensile. That means that this bar is linear, but this one is not linear. That's why the envelope show is. But if you want to go through and see more information, that means that you don't want to see the envelope directly. You want to see the force diagram. Feel free, of course, to come here and you see that we implemented the combination we call nonlinear, so you can go through them. This bar have tensile element. But if I go to another one, maybe this first one, I choose here, we have another tension element. If I go, it seems that I didn't change it, maybe. Okay. When we have a continuation with the combination, the value NL, that means that they are not linear. So you can see result for single nonlinear combination or to the traditional linear combination. No? If we go with the rolled or rolled bill steel, these are so all information are still available. If you still continue with this, you go to analysis and we go to the check element or the ULS check. When we choose the bar, we see that the verification the program make, of course, will run with the tensile forces we introduced in this point. So when I make the zoom, we see this is nice. If we come back with the analysis and now we go to the deform shape and come to plot, we can verify what is happening, of course, in the shell element. If we go to the deform shape and we go to a contour plot, we change it. Instead of stresses, we will go to the maximum bearing. So we have the possibility to choose any of the combination we want to verify the bearing in the point, and we see that is always positive, compressive in the direction we choose when we define it. So this will be common to the normal way of working with the program. You see that it's very suitable, it's very implemented. If we want to see another job, we permit another situation where we use this in a traditional job like this, where we have a tour, electrical tour. We see that the load case, we put 3 wind load which are compatible for the way the wind load will act for this type of structure. In the bar described, we can see that all the bar was described like generic only tension. I don't make the running another time. Simply I will go to the force to see result. If I choose envelope, I consult value. Anytime we have traction. Why we have traction? Because we make a nonlinear analysis. So that's why all the combination we we only have, of course, in the linear analysis where we use it to verify the nonlinear analysis. No, of course, any of this combination we can decide now if we don't want it to act in the verification, and we can say the loss step, the tolerance, but this is the same. The default value would make it to work. So this combination will transfer from the linear combination to nonlinear to permit me to verify them. If the program remark that in one of these combinations, this bar have a compressive element, it will be removed, of course. No, that's why the program make this analyze quickly. So this is the way we implemented the nonlinear analyze. If we want to talk about the booking analyze, when some element, let me select show job standard cases. I just put the typical case of bar, no, we already know. So with different situation, if we remark what I introduced in this job, we can go to the bar. We have the possibility to book link. When we choose any bar, program will give you the information we introduce. The book link coefficient is very important in this implementation. And the bottom, we have assigned criteria for booking analysis. That means that before this module, the user have the possibility to fix with his own criteria the coefficient to multiply the length. You can put this coefficient according to the case you have. You can also put directly the length you want, and you can use a simplified method to generate it. So the implementation we do, we use a advanced mode to help you to calculate the effective length. No, in this case, we will give you the coefficient to multiply the section, the length you have, and they describe the bar. So this menu of the book link have changed. We add this assign criteria for the booking analysis, which is another method we just update inside the program, the module we are presenting. So we have the possibility to considerate in the booking analyze the bar we are choosing. If we don't want the program to spend time to analyze this, we have to uncheck it. If before the analysis being made, we want the program to take information and assign to the bar, we have to check this possibility. So this will be very important. So if we don't want the program to make consideration of this, we can, for all bar, we can make this. If I choose all bar, I don't want him to change these parameters to conserve them. So I will just keep this, and simply I don't want this bar to be considered in the booking analysis program. Now if I go with bar describe, I use this option to fix that. All the bar are not considered in the booking analysis. Let me, where is my when I go with bar booking, when I choose this bar, you see that it's unchecked. It's unchecked. So if I want program to make analyze of booking, I will focus myself in this bar only. So I come here, I choose this, I accept, and now I go to the booking analysis. When I go to the combination, I'll see the combination I want to be analyzed in the booking. We can take the default one from the linear analysis, as we already comment, and we can create the new one. This one is enough. So we go to the booking analysis and run the analysis. This window is very important because it permits us to fix the mode we want to analyze. Normally, I only want I only have one bar to be analyzed. I don't need a lot of mode, but I will have it like this. Also, we have the possibility to filter the eigenvalue because biggest eigenvalue are securized, so we don't need to spend time to analyze mode when we have a very big value. The manner program will make discretization of this bar. We can choose the number of spam or the maximal length of the spam. These values are correct. Also, in order to don't spend time to analyze bar which the factor of the force in the combination divided by the force resisted of the section is less than 1%, 1%, we don't need to make the analysis, no, spend time. When the analysis is being made, we can allow the program to set this coefficient which were analyzed to the bar. So when we check this point and accept, so when we come back to verify value described, you see value buckling, we see that the assigned value was assigned in this bar. That means that this bar have the canonic description that it is pinned and free in the extreme. Normally, we are waiting a value of 2 in the like a coefficient of length, no, to be calculated. It was well done. If we come back with the buckling analysis and force the program to show us the buckling mode, of course, if we select the format shape, we see that we force the program to make only analysis for this bar. So when we change the different mode according to the load, we see different way of buckling. Of course, a buckling with a factor of load which is very high, of course, will not decide the coefficient we need. The lowest value, it is 1. So, but we analyze a lot of way of buckling, we are not necessary. No? So the program also have a sensitive analyze. If we are closer, we can know the participation of this mode. In this case, all the rest of bar don't have participation of the mode because there's like a single structure. This will permit us later to assign value to bar we have a minimum of participation in the same mode. This is a way to see that. Normally, we have also assigned buckling coefficient. But if you remember, I already said in the program to take this. That's why he assigned me this value, buckling. We have this value which is assigned in this point. Of course, you can ask me, this job is why we repeat the same configuration, because I was trying to see the difference with another program, and I remarked that the sensibility of Cype is very good, because in this job we can see that the load is the same. I put a 1 ton on the top, and I repeat different configuration. Here we can see that all these bars at the left have also the self weight, but the one on the right don't have the self weight. So if we go to the analyze of buckling, I do later because before we make it now in the buckling, we can see that the calculation is very accurate in this point. In this type of behavior, when we have pinned and pinned, we have 1. When we have fixed and cast in the top, we have 0.5. In this case, we have 0.7 and 2. This is the normal way of calculation. But in the same situation, in this point, we have simple differences. So why we have differences with the normal calculation we just make by hand, no? The difference is the consideration of the shear deflection. So if you see that in this point, we don't have exactly the same value if we make a calculation, because normally when we make calculation by hand, we don't take account the self weight of the bar. In this case, I didn't take it, but the shear deformation was very important to have this simple difference. In the back point, when I describe it, you see that I have a very big section. This big section avoid the deflection by consideration the shear forces. So that's why we have exactly the same value we was make theoretically. So that means that the fact of taking account the self weight of the bar and to take the shear deformation give you a light difference, no, with the conventional way to make calculation. That means that this module permit us to have accurate result, real result, no, and it permit to assign the value. That's why in this point we have a light difference, no, with the value we are waiting. So this means that the module is very nice, no? If I go to file management, let's see where.
Everything looks very interesting, Antonio. Thank you. What you're showing us is quite interesting.
Well, I just want to show another thing, and it will be open. You see,
Perfect.
all this implementation of non-linear permit us in the future to make coming soon important modification, no, in the use of OpenSys for the seismic calculation of non-linearity will be done soon, no. So, and the lateral buckling also, no, because this is prepared. In this job, we can focus our attention in this how to say, truss, no, the central truss. How we use it, of course, to analyze the buckling for different elements, no. When I change it, we can see how this element act, no. We can force the shape. So this will permit to assign the correct value of the coefficient. So that this is a nice way for different type of job to reach this value. We were very difficult, no? Because normally we have the canonical case, but when we go to the buckling another time, we choose this. Normally, when the case is different and the structure is, it can move translational, so we need to have the exact value we'll need, no, to this point. So this option will permit us to reach to this value, no, we are analyzed for this type of job. So for me, this all, I didn't talk about the possibility, no, in the report. When we make the report of the project, file, report, we also have the possibility to make output of the buckling analysis. This was also implemented. Of course, for non-linear element, the report of the verification will include this. So if, let me, to not saturate this information, just go to the buckling mode, okay. I will choose bar. We have a participation of 20%. The report go to another screen. I bring it here. So, what's happened? A moment, please. I lost job. Let make it for this standard case, so it will not take time. Tools, report selection of element. We have this report. According to the mode we select, we have the name of the mode and the factor of load. To multiply the load we have in this combination, no? To have the critical axial force. According to the combination and also the participation of this mode, summarized bar, where the factor were being taken, which mode decide the alpha value. Well, for me, this is all for this presentation.